Welcome back to another tutorial in which we are going to discuss about the surface area and volume of polyhedrons. In addition to that, we will also learn about what is the fundamental definition of a polyhedron. Okay. Well, the simple concept is a polyhedron is a three-dimensional object that has straight edges. And a simple way to understand this concept is think about a polygon. A polygon is nothing but a two-dimensional object that has straight edges, right? Just like a square, a rectangle, or a triangle. All of these are polygons. A quadrilateral, right? A circle is not a polygon because it doesn't have a straight edge, correct? Just like that, a polyhedron is a three-dimensional object that has straight edges. So just to make it easier, I have brought here variety of three-dimensional objects, okay? So out of these 5 objects, we'll try to figure out which one is a polyhedron. So the very first one here is a cuboid. As you notice, a cuboid has all the straight edges, right? Any edge you pick, it will be a straight line. So we will say that, yes, it is a polyhedron. Just like that, the shape number 2, it is a cube. And just like a cuboid, a cube also has all straight edges, correct? Every face contains 4 edges and each one of them is a straight line. So we will say that yes, it is also a polyhedron. What about shape number 3? In shape number 3, it doesn't look like a polyhedron because it has a curved edge, just like what you see here in the red, correct? So this is the boundary of a cylinder and it is a curved edge. Hence we will say that a cylinder is not a polyhedron. I'm going to jump straight to the shape number 5. It's a cone. It also has a curved edge, right? Just like this. So we will say that this is also not a polyhedron. And keeping the same fundamental in mind, we will say that the shape number 4 also contains straight edges, just like what you see here. Every single edge is a straight line. So this is an example of a polyhedron. Right. So now we know the difference between a polyhedron and what is not a polyhedron. Okay. So the next and most important topic, how do you calculate the surface area and volume of polyhedrons? Okay. So let's go take a look at some examples. So let's take an example of a cuboid in which we will go through how do you calculate the surface area and the volume with these specific dimensions of a cuboid given to us. Okay. So the fundamental thing you need to remember is that when you calculate the surface area of a cuboid or a three-dimensional object, you are essentially calculating the surface area of each one of its face that contains the three-dimensional object, right? So how many faces you see in this three-dimensional object? I see that there is one, which is the right-hand side of this cuboid. Then there will be one which is directly opposite to the right-hand side and it will be identical to the area number 1, right? So that will be 2. Then there is one at the top right here. This will be 3 and there will be identical to that at the bottom and that will be the surface area number 4. Then you will see that there is a surface which is the front side. I will label this as 5 and then there will be one identical to that, but it is the back view of this three-dimensional object and I will label this as 6. So in sum total, I have 6 different faces. If I know the surface area of each one of those faces, then the task is very simple. I just simply have to sum them all up and then obtain the total surface area of my three-dimensional object, right? So taking a look at this face, what do you see as the dimensions of the area number 1, right? This is nothing but this dimension, which is the depth, and this dimension, which is the height. So what if I simply plug those numbers in? So I will say that the depth is given right here. It is 4 centimeter, right? We use the word wide interchangeably with the depth. In this case, I'm taking this dimension as 4 and the height is 6, which is this dimension. So now it is very easy for you to calculate the surface area of the face number 1. It will be 4 times 6 or it is 24 centimeters square, correct? And just like that, you will say, of course, the surface area number 2 will be identical to the area number 1 right here, correct? So it will be also 4 times 6 or it is 24 centimeters square. Then I am going to focus on the length and the depth, these 2 dimensions. That makes up my base of this cuboid, correct? And what are those two dimensions? Well, length is very simple. It is 10 centimeter long. So this dimension is 10 and the rectangle contains this second dimension, which is 4. So I will say the base, which is the area number 4, it will be equal to 10 times 4, or it is 40 centimeter square. And identical to that is the area number 3, because this is the top view of the same rectangle, correct? So that will be 10 times 4, and once again it is 40 centimeter square. What about the remaining two areas, which is 5 and 6? 5 is the front side and 6 is the back side. So let's take a look at the number 5 first. The face number 5 is this front view, the one that contains the length, which is 10 centimeter long, and the height, which is 6 centimeter long, right? So it will be nothing but a rectangle that has dimensions 10 and the dimension 6. So it will be 60 centimeter square. And 6 will be nothing but a face which is identical to face number 5, except you are only looking at from the back side, right? But the area will be identical, so you can say it is 10 times 6, which will be 60 centimeter square. So the total surface area is what in this case? The total is a sum of all of these individual areas, right? So that will be 120 plus 80, 248. So it will be 248 centimeter square, right? So it was rather simple to obtain this total area. You took this entire shape and you calculated the surface area of each one of the face that builds up this three-dimensional object. And that's how you calculate the surface area. Now let's do a quick calculation of the volume. Well, the volume is nothing but whatever you consider as the base of your three-dimensional object. Let's say this is my base. It has two dimensions, right? Length and the depth. So the area of this base will be whatever that area is, and then I'm going to multiply that with the height of this object, right? So the area of this base is going to be 10 times the depth, which is 4, and the height is given here, it is 6. So 10 times 4 times 6, it is 240, and the volume is always measured in cubic units, so it's centimeter cube. All right. So in this case, the task was rather simple, that you obtained the total surface area by calculating the individual surface area of each one of its face, and you obtained the volume of this shape by simply multiplying the base area with the height, right? But there are other shapes in which it won't be as straightforward as what we have shown in this example. But the key fundamental concept you have to keep in mind is the total surface area in a three-dimensional object is the sum of the areas of its individual faces. These are the faces that build up that three-dimensional object, right? And the volume is nothing but a calculation of area of the base of that shape multiplied by the height of that shape. Okay. Now, there are a variety of shapes in which this won't be as straightforward as we are showing here for the volume calculation. Okay, but because of the shortage of the time, we cannot go through each one of those shapes and give you the formulas. We have defined each one of those shapes, such as a cube, a rectangular prism, a triangular pyramid, a right rectangular square pyramid. All of these are polyhedrons. So we have defined the volume calculation and the total surface area calculation formulas in this summary sheet, and this quick summary sheet is available in your study guide. Okay, we can simply use these formulas and obtain the required surface area or the volume calculation of that specific polyhedron.